12.5, circles in the coordinate plane. So the equation of a circle with center at HK, this is something that you should get used to because you'll see this in future classes as well. H in these equations is always the x coordinate of the center. K is always the x coordinate, sorry, the y coordinate of the center. And then R is your radius. So the equation looks like x minus h quantity squared plus y minus k quantity squared equals the radius squared. X and y values here are coordinates of any point on that circle. And this equation is called standard form equation of a circle or the standard equation of a circle. So you might hear both terms at some point. Just need to make sure that we have the understanding that they're both the same. So starting off very basic here, write the standard equation of a circle when you're given the center and the radius. Keep in mind the center always tells you your h and k values, and the radius is obviously r in this standard form equation. So once you have those two pieces of information, all you have to do is plug in the correct spots. So x minus 5 quantity squared plus y minus -2 quantity squared equals 7 squared. Now we just have to simplify anything that we can. So for example, y minus a -2, we would simplify that to show addition. And the 7 squared we would simplify to be 49. So the final equation would be x minus 5 quantity squared plus y plus 2 quantity squared equals 49. Increasing the difficulty a little bit, if you're not given one of those pieces of information, you have to be able to find it so that you can plug it into your equation for a circle. So here you're given the center point, and you're given a point that the circle passes through. So it's really a point on the circle somewhere. So what we're missing is we're missing the radius. Now, remembering that the center is always HK and that any point on the circle is X and Y, there's really two options. There's really more than that, but I'm going to go over two options on how you can figure out that missing piece, which is the radius at this point. The first option is to use the distance formula. So if we're finding the distance, we're really finding the length of the radius. We would take x and y, plug those either in for x2, y2, or x2, y1, and we'd have the h and k be the other values. So we would get the radius in this case to be the square root of 26. Again, just leave it as a radical for the time being. The second option is to actually use the equation of a circle. Because we have the h and k values, we have x and y values since we're given a point on the circle. So if I plug all those in, notice here in the y's minus a negative, I change to addition. This would give me 26, which means the radius, when I take the square root of both sides, is the square root of 26, the exact same radius that we found for the first option. So either way works. It's kind of just whatever you're most comfortable with. So once we have that, we can take the center and the radius and plug them into the standard equation for a circle. And then simplifying anything that we can for our final equation of x minus 1 quantity squared plus y plus 3 quantity squared equals 26. When you square the square root of something, the square and the square root basically cancel each other. Second thing we have to be able to do other than write the equation of a circle is be able to read the equation of a circle, pick out the important pieces of information, and then graph it if necessary. So if I'm given this equation for a circle and I want to find the center of that circle and then the radius so that I can graph it, the center is always within the parentheses with the x and the y. H is always with the x, k is always with the y. And when you pull those out of the equation, you have to make them the opposite of what they appear to be. So since this says x minus 1, the x coordinate or the h value is really a positive 1. And then a -2 for the k value since it says y plus 2 in the equation. The radius, this 64 represents r squared in the equation. So to find the actual radius, I just need to take the square root of that, and I would get 8. When we go to graph, first thing we should do is put our center point on the graph. So at +1, -2, we would put a center point. Now you'll see my entire graph shows up. But what was done here is from that center point, 8 units were counted out in the 4 main directions from that point, both up, down, left, and right. So then that gives me 4 points to connect with a circle. If you're going to freehand your circle, that's fine. Make it look as much like a circle as you can. Otherwise, you could use a compass here to make your graph even more precise. So where circles actually get used, especially when it comes to graphing, would be when you think about maps and you think about what everybody has to use nowadays, it seems like, which are cell phones, and you think about coverage and reception with cell phones, which comes from having cell phone towers that put out signal for us to be using. So what companies will do is they'll kind of lay out a map of an area and they'll place their towers so that they don't have any dead spots or they have as little overlap as possible, or whatever the case might be, however they decide to go ahead and do it for their specific company. So in this case, we have these 3 towers here that are shown to us, each with the area or the circular area that they would cover and provide reception to. So in Tower A, which is the circle A over here, has the equation that's given to us. If we are asking for the location and range of that tower, it's really not anything different than what we've talked about already. The location is the center point, and the range is really just the radius of that circle. So the location here is 1610, and the range is 10 units. Now you have to be careful here because each of these squares on this grid is 2 units if you look at the X and Y axis. So let's go back for a second and talk about the location. 1610, what does that mean? Well, depending on how the graph is laid out, in this specific case, we're working from this point O here. So point A, so that tower is located, since it's +16, most likely that's 16 units, whatever it be, miles, kilometers, to the east. And then +10 for the Y would tell us that we have 10 units in the north direction. And then again, the range being 10 units, this could be miles, kilometers, whatever it might be. We just have to make sure we're paying attention to the problem and using the appropriate labels that are given to us, if any are. So now writing the equation that describes position and range of Tower O, again, just have to understand position is the center and the range is the radius. So here from the graph, we have to be able to tell that the center is 0, 0, and that the radius is 12 units. So plugging those into the standard form equation of a circle, and then simplifying as much as possible, x squared plus y squared equals 144 would be the equation of that circle. Now we'll do this a little differently than we have in the past. I want you to pause the video after I'm done explaining, and you're going to complete these problems. So 6 through 8, you're going to be responsible for completing on your own, and then I'm going to have you check after all of them are completed at the end, and you're going to give me some feedback as to how many you got right and how we did. So go ahead and pause the video and complete those problems right now. Now that you've completed those problems, let's take a look at how you were able to do. So for number 6, if we have to write equations of these circles given centers and a radius, we have the 2 equations that you can see here. For number 7, this time we weren't given all the information that we needed to write the equation of the circle, so we had to use either the distance formula or the equation of a circle to find that length of that radius and then be able to write the equation. And then lastly, are you able to pull out the necessary information, being the center and the radius, to graph a circle? Now, keep in mind, there are other ways that you may need to come up with some of the information for your for your circle to be able to write the equation possibly. Some of those things are things that have been covered in the past, and you might be challenged to think of how you could find those things in some of the problems that you will see in the future now.